Move on with our exponential applications and learn our last two equations for growth and decay. So our first one we're looking at today is continuously compounded interest. So before we did compound interest, now we're going to look at what happens when it's continuous. So continuous is just when the number of times our interest is compounded increases to infinity, and this is the equation we're going to use. So the key to continuous growth is we're always going to see E in our equation if we have continuous growth. So a lot of this is the same. Our P is still our principal, our R is still our interest rate, and this is the equation we're going to plug it into. So let's take a look at number one. So for number one, $4,000 is invested at an annual rate of 6%, compounded continuously, so this is what tells me this is the equation I'm going to use. 4,000 is what I'm starting off with, so that's my principal. And then I have an annual rate of 6%. Again, make sure that you're turning this from a percent into a decimal, so this is 0.06. And now we're just plugging it into our equation. So since my P is 4,000, I have 4,000 E to the power of my rate, which is 0.06, and then I have T. So this is my equation. And part B is asking me how much will be in the account after 5 years. So 5 years, 5 represents my time. Alright, so for this all I gotta do is plug into my equation, so 4,000 E to the 0.06 times 5. So really I'm just plugging 5 into my equation, and I can put this into my calculator and get my answer. So in my calculator I'm going to type in 4,000. E is the button that is, there's actually two of them. I'm going to use the one that's second LN. So I'm going to push the second button, and then the LN button, which is the one right next to 4. So second LN gives me E to the power of, and then I'm going to type in 0.06 times 5. So be careful, the 0.06 and the 5 are both exponents, so they should be up in the corner. Press enter. This gives me 5,399 point. So because this is measured in dollars, I'm going to round it to 2 decimal points, so 0.44. Units is dollars. This is how much money is going to be left in my account after 5 years. So notice in our last notes, we did a quarterly and monthly, and now we just did continuously. So clearly, the more times we're compounding our interest, the more money we have. So if it's compounded continuously, which is just all the time, we actually end up with more money in our account. So this same exact principle can apply to things that aren't money, right? So this example is all with interest on money. Let's take a look at some examples that are just different than money. So this is continuous growth or decay. It could be growing or decaying. And we can, just like what we were just talking about, if it's continuous, we're always going to use E. So just like before, our A naught is the initial amount. Our K this time is our rate of continuous growth or decay. Let's look at number 2. So the approximate number of fruit flies in an experiment at time t equals 0 is 20. The fruit flies have a continuous growth rate of 3%. So the word continuous tells us our equation is going to have E in it. So if at time equals 0, this is right when we started, it's 20, that is our initial amount. So we know that A naught is equal to 20. We know our growth rate, in this case K, is 3%, which is 0.03. Again, we're going to use this to write our equation. So we have A of t equals my initial amount, which is 20, E, because this is a continuous, to the power of 0.03 t for time. So this is my equation I'm using. Our next part is asking us what is the population after 24 hours. So again, hours, this is time. So time is equal to 24. And we're looking at this equation. So we're just going to plug in 24 into our time. So we have 20 e to the 0.03 times 24. And again, this is something that we can just type right into our calculator. So 20, second ln to get you e to the power of 0.03 times 24. Press enter. This leaves us with 41.0 8, let's round it 9. And our units here for population, it's a population of fruit flies. So we're going to have about 41 fruit flies after 24 hours. The next section is asking you how long will it take for the population to reach 100 flies. So in this case, this is not time anymore. This is now my y. So y equals 100. To figure out this, I'm going to have to use my calculator. I'm going to type into y1 my original, and y2 is 100. So I'm going to go into my y equals. For y1, I'm going to type in my original equation from part A, so 20 e to the power of 0.03, and I'm going to type in x instead of t. y2, I'm going to type in 100. So I'm going to have to graph this. The first thing I want to do is figure out my window. So let me go to my window. I know I'm going to start at 0. For now, let me see what it looks like if I do 0 to 10. And for my y max, I want to make sure I pick something that is bigger than my y equals 100, because I want to be able to see y equals 100. So I'm going to type in 150 because I want a number that's bigger than this number. So let's see what it looks like if I just use 0 to 10 and 0 to 150. Okay, so when I graph it, I see two lines, but I can't see where they intersect. So I know I wanted to see more of it this way, so I'm going to have to make my window bigger on my x's. So instead of 10, let's say 50. And if we graph it again, so now we're looking at our lines. Do they intersect now? A little bit closer, still not quite. So I'm going to make it even bigger. Let's now use, let's say 80. So you do need to play around with your windows sometime if you can't see the entire graph. So let me draw a really quick sketch. This one looks good. So down here I got time in hours, and this is population in fruit flies. And I'm looking for the intersection point here. So I'm going to go second, calc, intersect, which is number 5. Go over to the intersection point. Type or press enter, enter, enter. It should go until it says intersection right there. So this intersection point is my answer. X equals 53.64, 3 decimal points, 8. Because this is my x value is time. So my units are hours. So how long will it take for the population to reach 100 flies? It's going to take about 53.648 hours. So on the back of your paper now, I have for you a summary of all of the different equations that we have. So we have 5 different equations that we're going to use. The 2 that we just learned today are the continuous ones. So whenever you see the word continuous, you know you're going to have an equation that has an e in it. Right. Half-life is easy because whenever you see half, you know you're going to use the one with half in it. Compound interest, it's always going to say compounded, and that's when you have your n. And if it's none of these, then it's just your plain old original exponential growth or decay. So these are the 5 equations that you're going to be using in this unit.